All right, this is going to be a long recording, so I'm going to just jump right in. We're doing the Finding Particular Solution worksheet, 11 questions with a lot of ABCDs. So let's get rolling. So the first thing we're asked to do is write the equation for line tangent. As soon as I see that phrase, I'm thinking slope and a point. Find the equation of a line. I need a slope and a point. The derivative, dy dx, tells me the slope of my tangent line, so that's where I'm going to start. So I have dy dx. Let me change this. What do I want? There we go. Sorry, should have had that ready. So I have dy dx equals, and my derivative is in terms of y. So I'm going to take the y value that they say. So at x equals 0, my y value is 2. So I plug in 2 into my derivative to find my slope. A lot of times your derivative is in terms of x. This time it happens to be in terms of y. 10 minus 4 is 6, so my derivative is 6. So now I'm going to my y minus y1. So they say at time equals 0, my slope is, or my point is at 2. So at x and y. So I have 6 times x minus 0, which is just x. Okay, next thing. Find the equation line tangent to curve at x equals 0. So that's what that is. And use that to find the slope, or the point at 0.5. So my y minus 2 equals 6 times 0.5. So y equals 3 plus 2, which is 5. So I can say f of 0.5 is approximately equal to 5. Find your slope using the derivative, and they'll usually give you the point, and then you just plug it in. Part B, find the second derivative. Well, my first derivative was 10 minus dy dx equals 10 minus 2y. So I'm going to take the point 0.02 and I'm sorry, I'm going to take the derivative and decide if it's concave up or concave down at 0.2. So my derivative, second derivative I should say, so d2y over dx squared. Derivative of 10 is 0. The derivative of a negative 2y is a negative 2y prime, but y prime is just my derivative. So then d squared, or the second derivative, is a negative 2 times 10 minus 2y. My derivative of a negative 2y is a negative 2y times negative 2 times y prime. And I know y prime, so I plug it in. Now my second derivative at the point 0.2, again, it's still in terms of only y. So my second derivative is going to be a negative 2 times 10 minus 2 times 2, which is 4, and I get a negative 12. Decide if it's concave up or concave down, and give a reason for your answer. Since, tell them how you know, tell me how you know what you know. Since d squared y over dx squared is less than 0 at x, at the point, I should say, not at x equals, at the point 0.2, at 0.2, implies that f of x is concave down. How do I know it's concave down? Because my second derivative is less than 0. Okay? Letter C, particular solution. So I know dy dx equals 10 minus 2y. And I want to solve for y. In order to integrate, I have to separate my variables. Put all the y's with the dy's. So this is, technically this is all one term. I can't just add 2y over here, or I have dy plus something, and that doesn't work. It has to be dy divided by something or dy times something. Same with the dx. Okay, so the whole entire 10 minus 2y has to come over to this side, and the dx goes over to this side. Integrate both sides. This becomes just x on the left-hand side. That's easy. Plus c. Sorry, on the right-hand side. On the left-hand side, if I'm going to do a u substitution in my head. No, I'll go ahead and write it. But here's my answer. It's a negative 1/2 ln of 10 minus 2y. The reason is because the derivative of my inside function is a negative 2. There's no negative 2 out here, so I need to get rid of it by putting in a negative 1/2. Here's my u substitution. U equals 10 minus 2y. Du equals a negative 2 dy. So dy equals a negative 1/2 du. dy comes out, negative 1/2 du goes in its place, and this becomes the integral of a negative 1/2 times 1, said that wrong, negative 1/2 times the integral of 1 over u du. Integral of 1 over u du is just ln of u, and the negative 1/2 is just being multiplied by that. But we can see that this negative 2 derivative has to be gotten rid of, so I put a negative 1/2 in there. Okay, multiplying both sides by negative 2 in order to solve. Raising both sides to the e raised to the negative, I can't talk, sorry, I'm trying to be in a hurry. 10 minus 2y equals e to the negative 2x minus 2c. And I'm going to do my little shortcut or my little trick. I'm going to just call that c e to the negative 2x. Pull this term as a multiplication, right? I can change that as e to the negative 2x times e to the negative 2c. And this is just a constant. So I'm calling that a new c. And that's what this is. Yes, I know these two c's will be different values, but it'll all come out fine in the end. Need more room. All right, so here's what we have so far. We have 10 minus 2y equals that. I'm going to do a little rearranging. Move the c e to the negative 2x to the left. Move the negative 2y to the right. Divide by 2, and I get 10 minus c e to the negative 2x times 1/2. Okay. Yeah, that's really good. So my next step, I got to find out my c value, put in 0, 2, whoops, equals y. Put in 0, 2. 2 is y, 0 is x, so I have 1/2 times 10 minus c e to the 0 power equals 2. This is just a 1, so I have, doing a little distributing, now I'll just solve. So I have 10 minus c equals 4, multiplying both sides by 2. So I have 10 minus 4 equals c, so c equals 6. Final equation. I'll leave the 1/2. 1/2 10 minus 6 e to the negative 2x equals y. And if I want to, I can go y equals 5, distributing it, 5 minus 3 e to the negative 2x. If you're with us in class, that's a little different order than I did. I think I solved for c back up in here, but that's all right. Notice we get the exact same equation though. Okay, find the particular solution. Done. There's my answer. Make sure you highlight your answer so everyone knows what you found. Okay, for this particular solution, what's the limit? Okay, so looking at this, what's the limit as x goes to infinity? As this goes to infinity, let me rewrite that. Y equals 5 minus 3 times 1 over e to the 2x. Right? Negative exponent means 1 over. As my denominator gets increasingly large, 1 divided by a larger and larger number goes to 0. 3 times 0 is 0. My limit equals 5. For the particular solution found in part C, find the limit as x goes to infinity. It equals 5. Okay. Number 2. Again, just going to keep on rolling. If you need to hit pause and let your mind have a break for a second, go for it. I got to keep rolling, so this is not a 2-hour recording. All right. On the axis provided, sketch the slope field for differential equations for the 9 points given. There's my derivative equation. A slope field is just a little tiny line segment representing the tangent line's slope at that particular point. So I'm going to plug in 1, 1, 2, 1, 3, 1, and so on. So when x is 1 and y is 1, I get 2 minus 1, which is 1, divided by 1, which is 1. There's a slope of 1 right there, so I'm just going to follow that basic slope right there. Now y stays as 1, so the top is still 2 minus 1, but the x goes to a 2. And so now I get 1/2. So following my pattern up 1 and over 2, I'm kind of shooting for that slope right there, a little bit flatter. Now we're going at 3, 1. So So x is 3, but y is still 2. So it's still y is still 1. So still 2 minus 1 over 3 this time, which is 1/3. And again, I'm shooting for that same slope, 1/3, up 1 over 3. And so it's going to be something like that, even flatter than that one. Okay, moving to the next one. Y equals 2. So I have 2 minus 2 on top. And if you notice that's a 0, it doesn't really matter what x is. These are all horizontal slopes. Make sure it looks clearly horizontal. Okay, next one. Put in 3 for y. So I have 2 minus 3 over 1, which is a -1. And then I have 2 minus 3 over 2, which is a -1/2. And it's the same as this, but it just is in the negative direction. So there's a -1, -1/2. I'm shooting for like something out here, so it's a little bit flatter. -3, maybe shooting for that point right there, so it's even flatter. And there's my slopes. Okay, letter B. Let y be the particular solution for the differential equation, doing the exact same thing we just did. Write the equation of a line tangent to the graph. I'm looking for the slope, so go back to my definition of slope. 2 minus y over x. 2 minus y over x. And I'm looking for it at 3, 1. So x is 3, y is 1. X is 3, y is 1. My slope is a 1/3. My point is 1, 3, so it's y minus 1 equals 1/3 times x minus 3. I'm looking for that at 3.5. So y minus 1 equals 1/3 times 3.5 minus 3. And I end up with y minus 1 equals 1/3 times 0.5. But since my 1/3 is a fraction, let's make the 1/2, or the decimal a 1/2. And I get 1/6. So y minus 1 equals 1/6. Adding 1, and I get y equals 7/6, or 1 1/6. All right, question C. Find the particular solution. Slide down here. There we go. Had nothing left of my page. Find the particular solution, doing the exact same thing we just did. My derivative, dy dx, was equal to 2 minus y over x. Put all the dx's on one side, put the 2 minus y, or the y's on the other side. So we have dy over 2 minus y equals dx times 1 over x. Let's put the 1 over x first. Equals 1 over x times dx. Okay, left-hand side, integral of a fraction 1 over something would be ln of 2 minus y. But what I notice, if I took the derivative of what's inside the denominator, I would end up with a -1 derivative. There is no -1, sorry, in my original problem, so I need a negative out here so that this negative and this negative goes back to a positive. So this is a negative ln. Right-hand side, there's no negative, just ln x. Moving the negative sign over, I get negative ln absolute value of x. Switching forms, and we get 2 minus y equals e to the negative ln of absolute value of x plus c. And I get 2 minus y, doing our little trick, making that just a capital C, e to the negative ln absolute value of x. I'm going to take this negative in front and move it up into the exponent because I can, and it makes things nice. And I get c e ln to the x minus 1. E to the ln cancels, and I get 2 minus y equals, nope, sorry, I already have my plus c. I thought I missed it. Equals c times x to the negative 1, which is 1 over x. So I kind of switched it back. This e and ln cancel. I get x to the negative 1, and I switched it back to 1 over x because I think it's going to be easier to work with. Okay, I'm going to go ahead and put in my values. Put in 1 for y, put in 3 for x. 2 minus 1 equals c times 1 over 3. This becomes a 1. Multiply both sides by 3, and c equals 3. Go back to here. 2 minus y equals 3 times 1 over x. I'm going to rewrite that as 3 over x. Once again, I put this 3 right back here. Whoops. Yeah, right back here. And 3 times 1 over x is just 3 over x. So 2 minus y equals 3 times 1 over x because of that. Switch places with these two. The negative y becomes positive. The positive 3 over x becomes negative. And I have 2 minus 3 over x equals y for x greater than 0. Why? Because of our initial condition. Somewhere it said that. I lost it. Anyway, it doesn't matter. The domain, they're not going to make you say the domain, so never mind. Ignore what I just said. All right, there you go. Those two. Hopefully that wasn't too disjointed on this question here. I kind of stumbled through it a little bit. Okay, I'm going to try to slow down. Question 3. Repeat of question 2. So repeating question 2. I'm going to plug in the different xy values into my derivative and calculate my slope and draw a little line segment representing that. So everywhere along this point right here, the x's are 0. And where my x's are 0, my derivative is undefined or vertical, so to speak. Okay? Oh, sorry, those aren't x equals 0. Those are y equals 0. Whoa, I almost made a mistake. So we have y equals 0, and x is equal to 1. 0 minus 1 is negative 1. Negative 1 divided by positive 1 is a negative 1. So here we have a negative 1. Something like that. Maybe a little too flat. Negative 1 slope. Now x goes to 2, but y stays at 0. And you can see then on top I still get a negative 1. But on bottom I have a 2. So I have a negative 1 half slope. So we're going to shoot for this kind of Angle again. Yeah, that one's probably a little too shallow. It's going to be a little steeper. And then this is going to be 1/3. Hopefully you can see that. This is still a 0. That's now a 3. And this will be a negative 1/3. Still shooting for negative or for positive 1 over there to make a negative 1/3 slope. Okay. When y is 1, 1 minus 1 is 0. So everywhere along these points where y is 1, my slope is 0. Okay. When y is 2, we have 2 minus 1 over 1, which is 1. So I have a positive 1 slope now. Now we have 2 minus 1 over 2. So we have a positive 1/2. And then a positive 1/3. Notice it's very similar to the other one we had, but just switched. These were negative and these are positive. Okay, that's it. Question B. Let y equals f of x be a particular solution, yada, yada, yada. Write an equation for the line tangent to the graph. So we're doing the exact same thing we just did back in 1 and 2. So we know dy dx. Hopefully we're getting very good at this. Dy dx was equal to y minus 1 over x. And we want to find it at 3, 2. So y is 2. X is 3. My slope is 1/3. Looking for the equation of the line tangent gives me y minus 2 equals 1/3 x minus 3. They want it at 3.3, so I have y minus 2 equals 1/3 of 3.3 minus 3. And we get what? Y minus 2 equals 1/3 of 0.3. Remember last time I went to a fraction? You totally could. 3/10. This comes out nice and neat. I can see that right away. So I have y minus 2 equals 0.1. Right? 1/3 of 0.3 is 0.1. Add, and I get 2.1. Had you gone the other way, this would be 3/10. Be careful, that's not 1/3. That's 3/10. This would go away. You'd get 1/10, and you'd add 2, and you get 2 and 1/10. Same thing I just got, but I just put it in a decimal form. Either 2 and 1/10 if you went to a fraction, or 2.1 if you stayed as a decimal. They'd take both. Those are both good answers. Question C, particular solution. Go back to my dy dx equals y minus 1 over x. Switch the switch the y and the dx. So y minus 1 comes here. Dx over x goes here. Integral of this becomes ln. Integral of this becomes ln plus c. Okay. Let's go e to a power. So we have y minus 1 equals e to the ln of x plus c. Bringing that c down, we get y equals c e to the ln x plus 1. But e to the ln x is just x. So we get y equals cx plus 1. That's pretty easy. Plug in the point, 3, 2. So x is 3, y is 2. So 2 equals 3c plus 1. Doing a little rearranging, 1 equals 3c, c equals 1/3. So final equation, y equals c times, nope. 1/3 times x plus 1. And there's my particular solution. It's kind of strange. A basic linear equation has a differential equation that looks like that. All right. That was it. Number 4. Once again, find the equation of a line tangent to the curve. So I needed to find the slope. So df dt. In this case, it's entirely in terms of t. So I have 48 over the square root of 3 times 1 plus 1. This becomes 3 plus 1 is 4. Square root of 4 is 2. 48 divided by 2 is 24. So y minus 32 equals 24 times x minus 1. At time equal 2, my function is 32. Sorry, at time equals 1, my function is 32. Use this equation to predict at time equals 2. So y minus 32 equals 24 times 2 minus 1, which becomes y minus 32 equals 24. X equals 56. And if you want to be more precise, 56 orders. In order to find the equation of a line tangent, I need the slope. Use my derivative. I need a point. They usually give it to you. Point slope form, y minus y1 equals m times x minus x1. Plug in the x, plug in the y, plug in the slope, and there's your equation. Put in the new point or the new time and solve. Okay, you're going to see that one. Guaranteed you'll see that on the final. Okay, letter B. Find the second derivative. So let's look at the first derivative. First derivative was df dt equals 48 over 3t plus 1 square rooted. I'm going to change that into 48 times the square root of 3. Nope. Times 3t plus 1 square rooted, and also on the bottom, so we need the negative. 1 over that makes it a negative exponent. Square root makes it a 1/2 exponent. So there's my df dt. I'm not using this. Okay, so d2, or the second derivative, is exponent rule. Power times the coefficient, so negative 24. Leave the inside alone. Times it by the, decrease the exponent by 1. Times it by the derivative of the inside function. Okay? Now, we want to find that at time equal 5. So I'm going to plug 5 into that mess and come up with an answer. So I get negative 24 times 3 times 5 plus 1 to the negative 3/2 power times by 3. I get 15, 16, square root of 16 is 4, cubed is 64, 1 over 64 because of the negative. One more time. This is 16, 15 plus 1, square rooted, because it's on the bottom, which is 4, to the third power, which is 4 times 4 times 4, 64. Negative exponent does not mean a negative number. It means 1 over. So this becomes 1 over 64 times 3. Do a bunch of reducing. 8 goes into this 3 times. 8 goes into this 8 times. 3 times 3 is 9. 8 times 1 is 8. And my ratio, or my rate, is a negative 9 over 8, or negative 1 1/8. Using correct units, negative 9 over 8. This was already where'd it go? Orders taken. So it's orders per hour. So the df dt is orders, change in orders, sorry, not orders per hour, but change in orders per hour. So this would be the change in orders per hour per hour. Okay, so the number of the rate at which the orders is changing, the rate at which the rate is changing, is negative 9 over 8, or the number of orders is decreasing, not the number of, sorry, you gotta be careful on that. The rate at which the number of orders is being taken is changing by negative 9 orders, 9/8 orders per hour every hour. Woo. Yeah, be careful on your verbiage. Okay. Find the expression for f of t. So now we're doing our separating of variables and so on. So I haven't talked through the point value yet, so I'll do that as we do this one. So we know df dt, and I'm going to go ahead and rewrite it like an exponent. Not like an exponent, but in an exponent form like I did right here. So I'm going to separate my variables. So df, there's no f's over here, so I'm going to leave it alone. And put my dt here. Most of the time, there's a +1 right there. You got a point just for separating your variables. Okay, next thing. I'm going to integrate both sides. Integral of df is just f. Add 1 to the exponent. Leave the inside alone. You can't touch the inside. Add 1 to the exponent. Divide the old coefficient by the new exponent. Whoops. How about I do that correctly? That is not a positive 1/2. That is a negative 1/2. This is a positive 1/2. So I add 1 to the exponent, divide the old coefficient by the new exponent, and I get 96. Now, if I were to talk through the derivative, when I take the derivative, I go this times this, decrease it by 1, and multiply it by the derivative of the inside function, which would have a times 3 out here. But I don't want a times 3 out there, so I'm going to have to get rid of it by putting in a 1/3. If I were to take the derivative of this, I would have 1/2 times 96 is 48, decrease the exponent by 1 gives me this, leave the inside alone. Then multiply by the derivative of the inside, which gives me a 3, but there is no 3, so I put a 1/3 to get rid of that and have it a 1. Okay. We get 2 points for that. 1 point for taking the correct integral and 1 point for remembering c. Now, sometimes depending upon how many questions there are, how many parts there are, sometimes you won't get a point for the plus c. You'll get a point when you solve for the c. Okay, so right now I'm going to solve for c. For those of you who don't solve for c and you integrate for, I know some of you do, and you integrate from 1 to 8 where I started to what I want, and you don't put the plus c, you'll get the point for that because you did take that into consideration as long as you put your, where'd it go? Plus 32 at the end. At time equals 1, or you can go 32 plus at the beginning. Okay, this kind of takes the place of that plus c. If you just integrated and didn't have the 32 plus, you would get points for the integral, but you would not get the c or the plus c points. Okay? You want them all, so remember that. Starting at 32, we're adding the change from 1 to 8, and the total answer would be where we end up after at time equals 8. Okay, so I'm going to keep going here. Plugging in 8 for no, plugging in 32 and 1, plugging in 1 for x, 32 for y, gives me 32 equals 96 times 3 plus 1, because I plugged in 1 for t, to the 1/2 times 1/3 plus c. 1/3 of 96 is 32. This becomes a 4 divided by, not divided by, but square root gives me a 2. And 32 times 2 is 64. This is 4. Square rooted is 2. 1/3 of 96 is 32. And 32 times 2 is 64. So c, subtracting 64, c is a negative 32. Okay, take that negative 32, put it right back in here. So I have f equals 90, no, I'm going to make that a 32. 32 times 3t plus 1 to the 1/2 minus 32. Okay, now they wanted at time equal 8. So I'm going to go 32, plug in 8, and I get 24 plus 1 is 25. Square rooted is 5. This becomes 160. Minus 32 is 128. All right. I think that's good. I've done 4.5 hours. I've got 7 to go, but the other ones are easier. Okay, I think we're good there. Question 5. In a popular book series, etc., we have that equation that represents the rate of change. Question A, write an equation. Here we go again. Write an equation. So dB dt, I need a rate of change. I need my slope. Hopefully we're getting good at this. Find the tangent line at time equals 12. So dB dt at time equals 12. Plug in 12. That's not a 5. Square root that, plus 1/9. Plug in 12. All right, this becomes 16. Square root of 16 is 4, so we get 5/4. This becomes 6. 6 squared is 36, divided by 9 is 4. This becomes 16 over 4, and I get 21 over 4. Y minus y1, which was, where'd it go? 36 equals my slope, 21 over 4 times x minus 12. Typically you get a point for that. And now we're going to take the 10 and plug it in and work it out. Y minus 36 equals 21 over 4 times a negative 2, because 10 minus 12 is a negative 2. And this becomes y minus 36 equals a negative 21 over 2. Adding 36 to both sides, which means I'm adding 72 over 2, gives me a grand total of, whatever that is, 51 over 2. Divide that and I get 25.5. 25.5 what? Books sold, and they are in somewhere. They're in hundreds of books. So this is 25.500 books. 2,500 is 2,500. So y equals 2,550 books sold, or sold at t equal 10 hours. Okay, letter B. Find B double prime, going back to here. dB dt. Wasn't it 48? No, 5. That was the other one. 5 over. I think I can see both. dB dt equals, I'm going to change that. 5 times t plus 4 to the 1/2 plus 1/9 t minus 6 squared. Derivative. This is great practice for back and forth from integrals to derivatives. Exponent times coefficient gives me 5/2, and decrease the exponent by 1, leaving the inside alone. Multiply by the derivative of the inside, which is a 1, which I don't need, but I'll put it there just to show you. I did remember, I just didn't need to do anything there. Multiply 2 times 1/9, leave the inside alone, decrease the exponent by 1, multiply by the derivative of the inside function, and there we go. Plug in 5, and I get 5/2 times 9 to the negative 1/2 plus 2/9. Plugging in 5 gives me a negative 1. and I end up with square root of 9 is 3. Negative makes it 1/3, and I get 5 over 27 minus 2 over 9, which is 6 over 9. No, 6 over 27 is what I meant. And I get negative 1 over 27. That seems different than what I had before. Yeah, that seems different than what I had on the board. All right, I just kind of went through our numbers real quick again. I must have done something wrong on the board. Anyways, negative 1 over 27. Interpret it in context. Book sold, negative 127. I think I had like 17 or something like that, or 11/7. I don't know. I might have done something weird. Negative 100 over 27 books per hour. Can't read my writing. Yeah, I'm not sure what I did on the board. I think what I did right here looks good, but I may have done something wrong here. That's a negative 1/2. Oh, there's my problem. Bummer, sorry. This should have been a negative 1/2 to start with. Some of you may have caught that, right? Yeah, that was a negative 1/2 to start with. So when I decreased this by 1 and when I multiplied this became negative, and this would become 2/3. Yeah, sorry, that makes that. Let me just do it real quick. This becomes 3/2. That became negative 5/2. That became a negative 3/2. This becomes cubed. Is that good? Negative 5/2. Square root is 9. Times that's 81. This isn't a 9 anymore then. If you remember what we got from the board, it's probably the right one. This is a 2. And this becomes 3. This becomes 27. I don't know. I made a mistake there somewhere. All right, sorry about that. I wanted to stop before I was just rambling on the recording. So this becomes 1 over 27 because the square root of 9 is 3. 3 cubed is 27. Negative makes it 1 over. 2 times 27 is 54. The negative sign is still there, so I get negative 5 over 54. This is 2 over 9. Common denominator is 54, so I times top and bottom by 6, and I get negative 17 over 54, which is what I did have on the board if I remember right. I don't have it up anymore, but so it's negative 1700 over 54 books per hour. Okay, sorry about that. I hate stumbling through those. All right, question C. Going back to our correct model with the negative sign in there, dB dt equals 5 t plus 4 to the negative 1/2 plus 1/9 t minus 6 squared. Double check I started off right. T minus 6 squared. Okay. Yeah, that's hard doing 11 problems in an hour. Okay, let's separate our variables. Leave the dB on this side. When you do this, it really is important. I know it may not seem like it, but you do need to throw parentheses around the entire expression that is being multiplied by dt, because all of this is being integrated with respect to t, and we need to show that. And the way we show that is with this dt afterwards. So all of this needs to be with the dt. And then when I integrate, I'm integrating all of this with respect to dt or with respect to time. Okay. Got to make sure I'm still recording. Okay. I've paused a couple times. So I got to make sure it's still going. All right. So integral of dB is b. Add 1 to the exponent. Divide the old coefficient by the new exponent. Multiply or look at my inside function's derivative. There's nothing there, so we're good. Same logic over here. Add 1 to the exponent and divide the old coefficient by the new exponent. Dividing by 3 is multiplying by a third. Leave the inside function alone. Raise the exponent to a 3. Like we said in class, that seems like that's cheating, but it really is okay because the derivative of my inside function is just a 1. That works. Had this been a t squared or something else, I'd had to do some modifications and it wouldn't have worked. All right, plus c. Plugging in my initial condition to find the c value, which was 12 and 36. Whoops. So 36 is b. I think on the board I did it the other way just to do it differently, but I'll do it defining c this time. On the board I did it different. And this was a 12. Okay, so this becomes a 36. This stays as a 10. That's a 4. So this is 16. So this is 10 times 4. And this is 1/27th times, what is that, 9? No, 6 times 6 cubed. Remember our shortcut, I can think of this as 3 times 3 times 3. And this is 6 times 6 times 6. This is going to cancel and make it a 2. This is going to cancel and make a 2. This is going to cancel and make a 2. And so I get 8. Okay, so this whole mess is 8. So I have 36 equals 40 plus 8. 40. And so I'm going to subtract, and I get, there's a plus c on this. And I get c equals a negative 12. Going back to here, we have b equals, as you can see, I think the integral technique is maybe a little faster, maybe a little less calculations, but I don't know. Whatever you like. I've done it both ways. I did it that way in class. I'll do it this way here. Okay, plug in 21. And I get b equals 21 plus 4 is 25. Square root of 25 is 5 times 10 is 50. And we're going to do our little trick again. I'm going to write this as 3 times 3 times 3. And this is 21 minus 6, which is 15 times 15 times 15. These 3's are going to cancel, get 5's all the way down the line. 5 times 5 times 5 is 125. Plus 50 is 175. Minus 12 is 163 books. All right, I got 15 minutes. I may not get done. All right, which of the following is a solution? Switch our places. dy over y minus 2 equals x minus 2 times dx. Integrate both sides. I get ln. Integrating, I get 1/2 x squared minus 2x plus c. Switching forms, y minus 2 equals e to that mess, and I'm going to bring that c down in front. So it's going to be c times e to the 1/2 x squared minus 2x. Adding the plus 2 on the end gives me letter B. Wasn't so bad. Question number 7. Question 7. The general solution to that is this. Let y be the particular solution. Which of the following is an expression for the domain and the domain? Okay, So we're going to do what we've been doing. We're going to switch places, but kind of. This one isn't as bad. So we're going to take the y, multiply it by here. So it's y dy. Take the dx and multiply it here. We have no natural log. It's just integrate that. We get 1/2 y squared equals 1/2 x squared plus c. Times by 2, we get y squared equals x squared plus 2c. And y equals the square root of x squared plus 2c. Initial condition is this here. So if we think about it, did I get a negative somewhere? They have a negative there. So my question then is, as I look at this, oh, that's why, because of my negative here. So right here, we're going to plug in a negative square root of 2. And that's where we get the negative here. So this initial condition, when x is a negative 2, y is equal to a negative square root of 2. So which one is it going to be? Is it going to be the plus or the minus? And it's going to be the minus. So the next question is, which one will it be? A or C? Okay, it's going to be A because I can't have the absolute value of x being greater than 2. I want the x to be less than the negative square root of 2. Okay? So the reason is, just real quick run through that. Whoops. The reason is, if we picture this right here, this can only be positive when this is greater than 2. So if x is less than the square root of 2, when you square that, so what's less than a negative, what is less than a negative square root of 2? How about a negative 4? A negative 4 makes that 16, and that becomes positive. What this says is I'm going both left and right, so I'm going to be greater than the square root of 2. Okay, so the absolute value. So this could be like a positive something, or I'm not saying that right. This could be 1, or not 1. Can't talk. This could be like a 2 or a 3 or a 4, and when you square that, well, or when we look back at our initial condition, it doesn't work because here x is a negative 2. Not talking about positives, so we don't know what happens on the right-hand side. My initial condition says I'm looking at the negative values. So I'm only looking at x being negative 2, and I'm only looking at y being negative 2. So this has to be negative, and this has to be negative. Don't want the positives also. Okay. Next one. Which following is a solution? Switch places. dy. We have a problem here. We have 2 x's or 2 y's. Remember how we solved that? We're going to factor out a y squared. Think of this as x squared, y squared. We're going to factor out a y squared, and I get 1, and I get x squared. Now I'm going to switch places. Nope. And I get that. I'm going to take the y squared, put it down here. Take the dx and multiply it up here. Integrate both sides. This becomes, think about what this is. I'm not going to integrate. I'm just going to switch forms. Add 1 to the exponent. Divide the old coefficient by the new exponent. Add 1 to the negative 2, I get negative 1. Divide a 1 by negative 1, and I get negative 1. Okay? This one, I just integrate this, so I get x. Add 1 to the exponent. Divide, and I get 1/3 x cubed plus c. Grab my initial condition that x is 3, y is 1. This becomes a negative 1 to the negative 1 power equals 3 minus 1/3, 3 cubed plus c. 3 cubed is 27, 1/3 of 27 is 9. 3 minus 9 is a -6. 1 to the -1 power is 1, because that's just 1 over 1. That becomes a -1. Add 6, and we get 5. So c equals 5. So I end up with negative y to the -1 equals x minus 1/3 x cubed plus 5. So remember what this here is. This means 1 over, so this is a -1 over y. All I'm going to do is switch places with these things here. Okay, so I get -1 over x minus 1/3 x cubed plus 5 equals y. And you might be saying, I don't see that anywhere. Well, yeah, you do. It's right here. If I multiply top and bottom by 3, that becomes a 3, just like this, and I get 3x, and I get x cubed, and I get 15. So this expression and this expression are the same. Okay. More the same. Switch places. dy or y dy equals x dx. Look familiar? End up with that solution there. Remember what we just said here. X is negative, y is negative. So which solution do we want? Do we want this one? No. Want this one. I want x to be less than the -3, not greater than not the absolute value to be greater than 3, because that's going. See if I can explain this one better this time. This guy here, remember we're starting at 0. I want all values that are more than 3 units away from 0. I'm looking at this mess and this mess in this problem. My initial condition's not talking about anything over here. My initial condition says I'm looking at -5. I'm looking at stuff over in this region, and the y value ends up being negative, so I'm looking at that value there. I like that better than what I did last time. I'm not sure how that skewed, but this lettering got all wonky. Predictor solution, more the same. So we're going to multiply by this, and I get 2y plus 1 dy equals dx. And we get y squared plus y equals x dx. Bell's about to ring. Hopefully I can get it done here in the next 30 seconds. I don't mean x dx, do I? I mean x plus c. Okay, you may not like this. I have 2 y's. Remember our trick we used before? We're going to factor out a y? Well, that doesn't help because it leaves me another y still inside. I got to make this a perfect square. I got to complete the square. So I'm going to add 1 to this side. No, I'm going to go back here. Sorry, I'm going to solve for c first. Give me less mess to worry about. Let's solve for c. Remember, I can solve anywhere. So I'm going to solve right here to make it easy. When x is 0, y is 0. So this becomes 0, this becomes 0, and c is 0. I like that. That helps a little bit. Gets rid of that c. So now I'm going to add 1, like I just said, to make it a perfect square. Not 1, sorry. Divide by 2 and square it. Add a 4th. Wow. So to this side, I'm going to add a 4th, right? Adding 1 to this, or adding this number divided by 2 and squared. So this becomes y plus 1/2 squared equals x plus 1/4. And then we're going to square root both sides. And then we're going to subtract a 1/2. Plus or minus. But according to the domain, oops, wow, what did I just write? I wrote the answer, and I was trying to write my original expression. So look at my domain. That's why I don't have the plus and the minus. It's because of the 0. I only want the positive part. So if I look at this answer here compared to this answer here, they're the same. Because I multiply both these by 4, top and bottom, and that'll give me 4 inside here, and I can make it a fraction and put a 2 underneath this. Give me a second. I'm going to finish here in a minute when everyone goes. Sorry. I got one more problem, and I didn't make it before the bell rang. Okay. I know you can't tell that I'm back, but it's an hour and a half since I last was working on this, and the bell rang, and it's 4 o'clock, and now I can just chill. Okay, so I actually totally forgot where I was at, but I think I was somewhere right in here, and trying to explain very quickly and not very well why this expression all of a sudden becomes this expression. So let's slow down and let's talk that through. So one more time here. Why can't I just solve this for y equals? Because I have 2 y's. And if I factor a y out of that, I still have 2 y's. I still got a problem. So that technique that we normally look at, it doesn't work. So I have to have a new technique. And the other technique we talked about when we talked about integrating was to complete the square. So I'm going to look at this expression, and I'm going to complete the square. There's a 1 here. My rule is to divide the middle term by 2 and then square it. So I get 1/2 squared. What I add to one side, I have to add to the other side. So this becomes 1/4. And I just left this as 1/2. I didn't write this as 1/4 because when I write these as my factors, like what 2 things multiply together, this term before I squared it is always what comes in here. So I just saved myself a little work. I just wrote it as 1/2 squared. So now the 1/2 comes inside, meaning this can factor into y plus 1/2 times another y plus 1/2, which I can write as y plus 1/2 squared. Okay, now I got to solve for y. So I square root both sides. When I square root, I generate both the plus and the minus. Okay, going back to our domain. We're looking at when y equals 0, when x is 0, y is equal to 0. So I'm looking at only the positive value, and if my graph is going to go up from there, because I'm looking at also a domain of x as being greater than a negative 1/4. But that really doesn't affect my final solution, except for we see that right here. Okay. Continuing, trying to solve for y. I'm just looking at the positive. I need to get this into a single term. So in order to add fractions, I need a common denominator. This is a 1, and this is a 1. So to make these common, I'm going to make this a 4 and multiply the top by 4. This gives me 4x plus 1 on top and 4 on the bottom, and I can put them together because they now have a common denominator. When I square root a fraction, I square root the top and I square root the bottom individually, or I can anyways. And so that's what I did here. I put the square root on the top. I took the square root of 4 and I got 2. I now have a common denominator, so I can put them together. And now I have letter D. That was much better, a lot less panicky. All right, final one. Question 11. Same problem, same process. I know my dy dx. I'm going to switch places. I'm going to integrate. I'm going to think of this as y to the negative second power. Adding 1 to the x1, it gives me a negative first power. Decreasing, adding 1 to the exponent, divide the old coefficient by the new exponent. And I got my plus c. Plugging in the initial condition of 1, 1. This becomes a negative 1 over 1, which is a negative 1. X is 1. c is equal to a negative 2. And so I have negative y to the negative 1 equals x minus 2. Multiplying by negative 1, I get y to the negative 1 equals 2 plus x. No, 2 minus x. Multiplying both of these by negative 1. This is 1 over y. And we've done this a few times, but let's just remind ourselves, if I have a fraction, I can I can switch anything that's straight across from each other. So this can go here, this can go here, this could go here, this can go here. We can switch this direction. So I have 1 over 2 minus x equals y. Now, initial condition says when x is 1, y is 1. So remember what we're looking at. Think about your slope field. So my question is, which one of these is the right answer? And so I want to find the one that is in my initial condition. So this one says for x being less than 2. And this says for x not equal to 2. And that is true. This is when x is not equal to 2, because that can't be equal to. But my initial condition says that when x is 1, y is 1. And so my solution to question number 11 should be letter D. Where to go? Question D, or answer D, because my initial condition satisfies that condition there. And if x is less than 2, then it's also not equal to 2. Okay. I think that should be good. That's well over an hour, so I'm going to call it good, and I'm going to go home for the night. Maybe, if I can find my pause or my shut off. All right, have a good night. See ya.